السلام عليكم. إن شاء الله تكونوا بخير. Today I will repeat the chapter 5, Introduction to Factorial Design, since the beginning, and after that I will complete the remaining parts, which is how to develop the factorial design. The learning outcomes of this chapter will be essentially to define the main effects and interactions between factors, to know how to deal about the factor factorial design, to know how to analyze these types of plans using the analysis of variance, the ANOVA, extended for the factorial design. And after that, we will check the model, the assumptions, the different simple sizes, how to use the post analysis of the ANOVA part regarding this factorial design. Okay, so for the introduction, you know that many experiments involve the study of the effects of two or more factors. In general, factorial design are most efficient for this type of experiment. And by factorial design, we mean what? We mean that in each complete trial or replicate of the experiment, all possible combinations of the levels of factors are investigated, okay? So if we have, for example, 4 levels for factor A, which is the main factor, and 7 levels for factor B, which is the main factor also, we have 2 main factors, A and B, A with 4 levels and B with 7 levels. Each replicate contains all 4 multiplied by 7 treatment combination, which are 28 combinations. Okay, for example, if there are A levels in general for factor A and B levels for factor B, each replicate contains all A, B treatment combinations. So when factors are arranged in factorial design, they are often said to be crossed. Okay, the effect of a factor is defined to be the change in response produced by the change in the level of the factor. And this is frequently called the main effect because it refers to the primary factor of interest in this experiment. Okay, let's see that in detail. So for the factorial experiment without interaction, what we have here, we have 2 factors, factor A and factor B. For factor A, we have 2 levels, okay? The lowest one is called minus and the highest level is called plus. Same for factor B. And if we will collect the answers or the responses for the combination factor A and factor B, what we will have 4 combinations. So we said before for the previous slide that if the A factor have A level and the factor B have B levels, we have in total A multiplied by B. So here we have 2 levels for A, 2 levels for factor B, so we will receive 4 combinations, okay? These 4 combinations will be as follow. So this is the first response for the first combination, this is the second one, this is the third, and this is the fourth, okay? So if I take, for example, the first one, this one, so it will correspond to the experiment when factor A is in its low level and factor B is in low level also. So here, for example, for the second part, if we fix the factor A in its lowest level, minus, okay, and we fix the factor B in its highest level, which is B, okay, we will receive the response, which is 30, that corresponds to the combination of low A and high B, okay, and so on and so forth for the remaining experiments, okay. طيب, what we can do here, this plot is called the 2 factorial experiment, okay, with a response y shown in the corners. So we have, as we said, A multiplied by B, which are 2 by 2, which are 4 experiments, 4 combinations for this experiment. Fine. Here we will try to calculate the main effect of A, B, and the combination, the cross effect AB, okay? How to calculate the main effect? We will calculate the mean of a response for A plus minus the average of the response in A minus, okay? Which are here. If we will fix our if we will fix our points at the highest level, which is A plus, what we will receive the average, we have 52 plus 40 divided by 2, okay? And minus the y bar A minus, which is what? Which is, if we fix our line here, what we will receive here. So the answer 20, the answer 30, and the average between that will be called y bar or y average A minus, okay? We will receive 21. Same for B. We will do the same thing for B when B is in its highest level, which is B plus here, okay? We will receive 30, 52 divided by 2 minus in its lowest level 20 plus 40 divided by 2. We will receive 11. For the interaction AB, what we will have, it will be as follows. The interaction, it will be as follows. So we will plot this part, okay? So this is the cross between both of them, okay? So what we will have here, we will receive the 52 plus 20 divided by 2 minus 30 plus 40 divided by 2, and we will receive the minus 1, okay? If you see here, if we try to plot the interaction between both factors, we will plot, in this case, factor A, y equal to fx. Y is the response, and f of x is the factor A, if we have function f, okay? In this regard, we will receive here the variables, well, the responses that correspond to the levels of A plus, B plus, and B minus, okay? When the factor A is in its lowest level, okay, which is here, okay, we will receive as responses for factor B in its lowest level 20 and in its highest level 30. You will receive here minus B 20 and here plus B 30, okay? When A is in its highest level, A plus, so what we will receive in this regard, we will receive for B minus 40 and for B plus 52. So you have here 40 and 52. As you see here, we haven't any interaction between both lines. Okay, we will link B plus, we will link B minus together, and as you see here, we have no interaction between both lines in this case. And in this case, what we will receive, that we can say that no interaction between factor A and factor B is considered, okay? This is justified also by the calculation of AB interaction, which is equal to minus 1. That means that's near to 0, which indicates that we have no interaction between A and B. Okay? We will repeat the same thing, but in this regard, we will have another case. And as I mentioned it before during the classroom, this is case B, case 2. Okay, so the previous slide is case 1 and this one is case 2. We modified here the values of y. As you see here, we have 20, 50, 12, and 40. Okay, and if we calculate again the new interactions, the new main factors A, B, and the interaction A, B, you see here that factor A have an a factorial value of 1. The main factor B has a value of minus 9. However, the AB is minus 21. Okay. In this regard, you see, if you plot this this graph, you plot it as interaction, as we did before in the previous slide. You can see here that both lines for B plus and for B minus are crossed. Okay. And in this case, we say that we have an interaction between both factors A and B. Okay? So when you receive values here that are near to 0 in the positive or in the negative side, you can say that the interaction is a small interaction. But if you have a value which is greater than 0 or greater than 0 in both sides, positive or negative sides, you can say that the interaction is considered, and in this regard, you have interaction. Okay? So for the definition of the factor effect, the change in the mean response when the factor is changed from the low to the highest level, okay? And if you take just a previous look for the previous slide, you saw that we link B plus to B plus and B minus to B minus, and we try to check the change from the low to the highest level. The factor effect have two characteristics, magnitudes and direction. If it's negative, that means that when you increase the factor from low to high level, the response goes down. And if it's positive, that means that when you increase the factor from the low to the high level, the response goes up. This can be also demonstrated and identified by the plots that we can do in the 2D or 3D using the software as Minitab. And that correspond to the regression equation that we can have. If you see here, all the lines, the isocontours here of the plots are parallel. That means that no interaction, we have no interaction between both factors. And in this regard, you see that if you determine the fitted equation to this model, you can see that the interaction to the interaction corresponds smallest value of coefficient, which is 0.5, which is the smallest value compared to the 5.5, the 10.5, and 35.5. And we can say here that this is the final equation that we have, and we can exclude the interaction. However, in the second case, as you see here, the isocontours are curved. Okay, they are not parallel, not totally parallel. And you have here, for example, a curved zone. Here also curved zone. And in this regard, you can see that the interaction is not excluded, and the interaction should be considered in this model. Interaction is actually a form of curvature that you see here in the contour plot. For the contour plot, all the lines from this point till the end equal to 34. Okay, for example, if I take this line, all these points, okay, correspond to 37 as y response. So for that, they are called contour plot, and this one, for example, correspond, all of the results will be equal to 34. Okay. In general, when we receive the factorial designed plan, we can plot what you can use the ANOVA part. For the ANOVA, for the factorial design experiment, you have A levels for the factor A, you have B levels for the factor B, and in this regard, we have also the replicates for each one. What we will do here, we will consider for the level 1, for example, factor A, and for the level 1 for factor B, we will have n replicates. Okay, so we will do we call that the completely randomized design CRD, and we will try to evaluate the ANOVA model as we saw that for the previous lectures. Okay, so the observation in a factorial experiment can be described by a model. There are several ways to write the model for the factorial experiment, and the effect model is equal to this equation. In this equation, we have, this is our new model, and we have the overall mean effect. We have the effect in the 8th level for the row factor A. We have the beta j, which is the effect of the G level of column for factor B, and we have the interaction between 2 and beta, and we have the error as we know that previously. Okay, this is the random for the epsilon. This is the random error component. So we can write the model. Another possible model for the factorial design can be written as follows. So we can write the yijk equal to the y, which is yij, which is the sum of all these parameters plus the component for the error. We so that before we did that for the case when we have one factor with multiple levels, for example, or for the block, for the case of block. In a two-factorial design, both rows and columns factors or treatments A and B are of equal interest. And specifically, we are interested in testing the hypothesis about the equality of row treatment effects. So for that, we can write the hypothesis with different manners. Let's say the first one regarding to the factor A, the second one is regarding the factor B, and also is regarding the interactions between the factors. So we can write these hypotheses for the model, for this model, and we now discuss how these hypotheses are testing a two-factor analysis of variance ANOVA. So for the ANOVA part, as usually, we need to establish the total equation for the ANOVA part. And in this model, you have to identify the different points that we need in this ANOVA. These are the various equations that we can use after that. And the final one is the SST that will be equal to the sum of squares for factor A, for factor B, for the interaction AB, and also for the error. You have here the degree of freedom and all the equations regarding that. The total table for this analysis of variance for two-factor factorial design the plan, you have this factor with all the sum of squares, the degree of freedom that corresponds to the A, B treatment, interaction, error, and total, and also the mean square and the F node. For the F node, we can identify the F node for the factor A, for the factor B, and also for the interaction. Okay, and you have here in the bottom of the table the effect and the degree of freedom that correspond to each. Okay. Manually, in general, we need to use a short equation to calculate the sum of squares manually, and these are the different equations that correspond to this point. Okay, so this is the first part for the chapter.